This is brought to you from the kitchen of snow, so get ready to have some fun. Today in this video, we are going to be talking about the scientific method. And in your 8th grade textbook, it's really called like designing an experiment. But really, anytime that there's a problem, people will use the scientific method. So, for example, it's Monday morning and you go and you pour yourself a bowl of cereal and you pour milk on top of it and you take a bite of your cereal and yuck, the milk is sour. So that would be a problem. So you would start the scientific inquiry, which is the process of gathering evidence about the natural world and proposing explanations about that evidence. So what you really need to do is narrow down what do you want to learn and what is your question. So you really need to define your problem. So you really want to know, why did the milk go sour? The second step is to research your topic. So you need to find out information, you need to use sources to gather information, you need to look to see if there's other experiments that have been done before. If so, what were the results of that? And so you need to gather some more information. For example, you know that you left the milk out last night and that you bought it 5 days ago. So then the third step is to create a hypothesis. So you need to make an educated guess about the results of your experiment. So you're almost going to predict what's going to happen. You need to use the information you already have. You need to use the observations about your topic. So this is a very educated guess. A good hypothesis can be tested. So if you're trying to figure out why your milk went sour and you know you left it out last night, your hypothesis could be something about, well, milk might go sour faster at higher temperatures. And that can easily be tested. And that gets us to our next step, which is designing an experiment. The experiment must be designed to answer the question. So if you're trying to figure out if the milk went sour or if the milk goes sour at higher temperatures, then you need to design an experiment around that. And it has to be a controlled experiment, which tests only one factor at a time against a control group. The control group is the object or group that's used for comparison when nothing happens, when there's nothing changed. And then the experimental group is where the object or group is changed. There are several different variables involved. The variable is a factor that changes in order to test the hypothesis. The independent variable is the one that's changed on purpose. Sometimes this is called the manipulated variable because this is the one that you change. So in our experiment, we want to change the temperature of the milk. So we're going to control the temperature of the milk. The dependent variable, or the responding variable, changes as a result. So we want the dependent variable to be how quickly the milk turns sour. So it'd be the amount of time it takes for the milk to go bad. Some things that we need to keep constant, though, we would need the amount of milk to go sour. We would need the thermometer to be the same. We want the milk to be the same age, so it needs to come from the same container because the age of the milk could be a variable as well. You have to be careful, though, to make sure that you keep bias out of your experiment because bias could be an error in the design. So if you all of a sudden, if you were testing milk that was already past its expiration date, that would be experimental bias because you don't know if it was the age of the milk that caused it to go sour or if it was the temperature of the milk that caused it to go sour. So it might make a particular result more likely. After you guys have collected your data, you need to analyze your data. The data are the facts, figures, and other evidence collected during the scientific investigation. A lot of times, scientists will make a graph about their data, and then they'll be able to analyze and look for trends and patterns within their data. This is also what we call empirical evidence. Empirical evidence is data that are collected using a scientific process. And then finally, draw a conclusion. What do our results tell us? Do they support your hypothesis? Was your educated guess correct? Or did it not? Did it kind of go against your hypothesis? And do you need to go back to the drawing board? You know, proving a hypothesis wrong is just as important as proving one correct. And then you need to make sure that your trials can be repeated. what could have been done differently, were there errors, and you need to have repeated trials. And in science, you have to have a lot of repeated trials in order for a hypothesis to kind of be accepted into the scientific literature. So in order to communicate your results with the scientific community, there has to be replication. So attempts by different groups to conduct the same experiment. So researchers might share their results with a colleague from another university or somebody from a different country. Many replications have to be ran, and the results have to be similar before the hypothesis can be supported. And scientists have to have a pretty good amount of skepticism. They have to have a very critical eye about these experiments in order to make sure that there is no bias, either personal, cultural, or experimental. So skepticism is generally good for science. And in conclusion, for the video, people generally use the scientific inquiry and the scientific method more than they might realize, so they just don't do as many formal steps with the scientific method. But it's a really good thing to know, especially since you're going to be solving a lot of problems. Have a good day.